Hi, everyone, and welcome to a new episode of the Tool Belt podcast brought to you by Plant Services. Today's episode is taking advantage of an event coming up next week for us, the first ever AVEVA iWorld Digital, happening from October 19th through 21st. And today we have with us Mike Reed, who's the manager of AVEVA's AI Center for Excellence, and he's going to talk to us about advances in asset management. Mike, thanks for being here today.
Well, thank you. Thank you very much, Tom.
For those of our audience who haven't met you, could you tell us a little bit about yourself and the things you're working on now?
Sure. I'm a degreed engineer by training, a mechanical engineer. I've been running the AVEVA AI Center of Excellence since its inception, and in prior I guess versions, it was also the Monitoring and Diagnostic Services Center for AVEVA, and we've my background comes from the actual real world side of things. I'm an engineer. I've had experience in power plants, both in design, construction, startup, operations. I've held positions of operator, ops manager, maintenance manager. And part of our goal is to be able to translate what comes in the software to the end user and to help that end user interpret what they're seeing and basically get the use out of it that they desire. And we're very instrumental in it. My team is made up of similar other engineers that are all focused towards that goal in asset performance management and also in other areas of our AI and software.
Okay, well, you're talking to the right audience because a lot of them probably have a similar story where they've moved between operations and maintenance, they've moved into management, seen that whole side of the plant works. And given that our topic today is how AI and machine learning are going to transform asset performance management, it's kind of a big topic. So in your opinion, what are most plants doing right these days when it comes to asset management, even before factoring in AI and machine learning?
Sure. So over the past couple of decades, most plants have adopted fully the concept of taking all the data and that big data that they're gathering and putting it into some sort of historian. So, for example, like OSI-PI. And that allows them to be gathering all this real world data about their equipment and putting it in there and start to gather insights just using straight historian analytical tools. So that part has really been, accepted as canon within the industry. Now, over the last decade or so, you've also added on top of this machine learning-based predictive analytics solutions and also condition-based management solutions. Condition-based, it's looking for certain thresholds of operation conditions to basically trigger actions out there. Simple, if I'm above a certain pressure, flag this, send something out, and then we'll have to take a look at that. Now, predictive analytics takes it one step further. It's taking a look at previous operations and understanding what is defining good behavior by analyzing through machine learning those good behaviors in the past to identify where those plants should be across multiple operating zones. And then comparing real world conditions to that in a dynamic evaluation. And then that could provide real world indication to that end user that we may need to take intervention. So plant operations, they've got a really good handle on the base types of maintenance. Your standard reactive maintenance, something fails, we fix it, right? That's everybody's at least has that part. But then going into preventative maintenance, taking those checks and services that have been recommended by the OEM or by good practice for regular checkups on the equipment. Condition based on top of that, we're looking for those thresholds you mentioned. Now, all of those being internalized, that next level is then the predictive maintenance, taking a look at conditions as they are in their incipient stages and to understand if I can take action when I'm made aware of this, can I avoid a larger failure or an unplanned outage? And can I be a little bit more efficient in that? So that's where we see most of the power market, for example, in the United States and also in the oil and gas market. They've adopted historians, they've adopted condition-based management programs and in their computerized based management systems, they've adopted some form of predictive analytics. So now you're looking at a layering on of that next generation. How can we turbocharge this predictive analytics into gaining further insights and leverage all that knowledge that's out there and putting it in the hands of the end user who's going to be making those decisions that can be risk-based? How's that?
No, that's great. And I like how you mentioned which verticals, some of the verticals that are adopting these kind of technologies right now. I think my next question would be then, we've got a lot of folks listening who sort of look over the fence at what the Joneses are doing to see what the next plant over is going to do with this kind of technology. What percent of plants out there right now would you say are really engaged with this? And does that mean they're doing projects, or does it mean they're looking closely at it? What's your sense?
My feeling there is that all your larger utilities have some form of this program in place right now. And to a varying degree, your independent power producers are also adopting that, whether they've been spun off from a large producer, or sometimes they'll pick it up when they get acquired by asset management that wants to get a good feel on what they own. And it's a combination of self-performed, using the tools that are out there, and also using software as a service or monitoring as a service to augment the softwares. So we've seen it all around. I'd say, let's say if I threw a number out there, 70% or so of the market is probably actively using this in some form or another, and the other 30%, is down that path, at least to the historian, and probably going a little bit further.
Okay, it's interesting that I see more and more presentations at events such as the SMRP annual convention, where people are presenting case studies on what they're doing with machine learning. Of course, at Pi World, the two times I went to San Francisco for that conference, there were a lot more case studies of people using these techniques and technologies. So the projects you're talking about, they're beyond the pilot stage, right? That people are,
Correct.
They're achieving results. They know what the ROI is for their effort.
Pretty much, and you can find out those kind of ROIs for preventative maintenance program by EPRI had a paper a while back, I think about 30 years now, but a while back, that explained how you could identify issues and then do a risk analysis on those issues happening versus what the actual cost would be if each one of those scenarios was taken to the end. You could develop an ROI. So if I have a bearing vibration that's running high, and if I go in there and take a look at it, I can see what the cost of scheduling a maintenance outage and scheduling the repair of that, versus if that develops into a greater problem and it becomes an actual catastrophic failure, what are those costs? What are your lost opportunity costs, et cetera? That's all common knowledge typically within the industry. So you can show the value of finding those issues in their early stages, as opposed to waiting for them to find you.
Okay. My understanding too is that AI and machine learning currently are more strategic technologies, in the sense that they aren't deployed on every single asset. They're more deployed on assets that are considered critical assets, or at least asset-specific basis. Is that your understanding too? Should I update my thinking on that?
Well, surprisingly, it does cover all the assets, but you do see them target those big return on investment. So your big prime movers, your gas turbines, your steam turbines, your big pumps, your big heat exchangers, the condenser, those kind of things are easy to show that value for. And they're also ones that have a lot of historical data behind it, that we know those modes of failure, and we know the effects of not taking those actions ahead of time. So if you're looking for that quick return on investment, yes, those are the biggest place where you're going to be able to focus it. But now we're starting to branch out a little bit further and we're getting to that next layer of insight and knowledge by taking the learnings on top of what we've been seeing with straight predictive analytics now, and start working into prognostics. So it's not only important to know when something's going to fail, that something's going to fail, but to know when something is likely to fail. So now I want to know, all right, what's happening to me? What is the likely scenarios? And how long do I really have, what's my event horizon for me to make a decision before it's made for me, right? And so as you continue to move further, that's where you're going to start leveraging more and more of the AI. In its simplest case, machine learning is a form of AI. But here now we want to start adding on other factors and other outside of the realm of exactly what we're looking at, getting other insights outside that normal scope of vision of the end user. And that will allow us to provide that much more insight to that person, not only that person who might be experienced how to make decisions, but you're also capturing that knowledge from other experiences to provide to that person, right?
Okay.
And so remaining useful life is one big thing. Prognostics saying, all right, if we see this kind of scenario happening, it's a likely, is it a bearing failure? Is it an alignment issue? Is it something else? What kind of task should I take to further my next level of operation, of investigation? Those kind of things can be turbocharged by AI to help bring that to the fore right in front of the end user to take a look at.
Okay. Well, if I could actually follow on a question on users and users looking at their assets with these technologies, is it useful for users to have a library of other assets to compare the performance of their asset against? Or are these technologies useful just to focus on a single asset, and like we said, use the data from the historian to go back in time and focus and zero in on the one asset? Or are these two things that might work together?
They work together. They do work together. Obviously, the most germane to your equipment is going to be how your equipment's running. Mm-hmm. If you buy a Ford Mustang off the lot, they all have certain specs and lines on that. But how yours depends versus the other person who bought the next model on the line. Once you drive them off the lot, they have different behaviors and different histories.
Yeah.
So yes, I should expect that they all should have certain commonalities. Mm-hmm. And so that data, that's more what you're talking about with the libraries and understanding, that we have certain modes of failure and operation conditions around that model, but then specifically augmenting it with your own specific equipment. Because same concept, if I install a gas turbine at sea level, and I have one that's operating up in Denver, they're going to have some different behavior capabilities and technology and characteristics. Mm-hmm. So same thing if I'm also operating things in parallel, or if I'm operating things by themselves. So that's that more knowledge that I have around it, the better it can help me with the insights. Now, what AI can help you do is organize that vast amount of knowledge around something.
Okay.
And also to see some of those factors that interact that you may or may not understand they do interact. Right.
I'm imagining a comparison of a truck being driven off a lot in California versus a truck being driven off a lot in Buffalo. And
right.
The ability to compare those data sets immediately to evaluate performance over time. One's going to be challenged more by the elements than the other. It's just a matter of figuring out what's most applicable to where your asset is sitting.
Right. And also to know, you many times you say, well, look, this guy here, he's running a little bit hotter than the other one. Well, it always runs hotter. Right. Well, if I try to use the same metrics on whether I work on a piece of equipment based upon fixed metrics, that's one thing. But if I can actually index the metrics to that one that's always running hotter, if I index that to its normal conditions, then I know when it's running hotter than that, that I've actually got an issue. And that's where indexing the historical data to how something's behaved to that piece of equipment helps eliminate some of that. I don't want to call flippance, but that's typically what will happen is sometimes that we as humans can discount something just because, oh, it's always done that, or it's always, behaved this way. And what we want to do is put this and present it to you in context to where then you can making informed decisions. And it doesn't assume that, the end user doesn't know anything about the equipment. I mean, what it's meant to do is augment this and organize it and present it back to them in a way that they can make use of it. If we think about the single biggest problem, if we would call it, of having so much data is having so much data, right? I don't know where to start or what to do with it.
Yeah.
I go back 20, 30 years when I was an operator, every midnight, a little bit after midnight, the little dot matrix printer would spit out a ton of readings and things like that from, and you go and you tear it off and you slip it down, you put it in the book. You never even really did much with it, right? Well, then if we don't do something with this data, we're generating a bunch of data for nothing.
Yeah.
So the computers enable us to at least do something with the data and then present it in a form that somebody can actually use it and it means something to them, right?
Well, let me ask you a final question, which follows up on your point about a lot of data here. Our listeners are pretty well versed with the kinds of different condition monitoring technologies commonly in use, vibration, infrared thermography, ultrasound. In your experience, are any of those technologies good complements for AI and machine learning in the sense that they might generate a lot of data? Or is it that applications for machine learning AI are limited only by the technician's imagination, really?
It really is some of that, is that how much stuff is available to us that we haven't even tapped yet.
Okay.
Straight numerical data that we're bringing in through vibration sensors or bringing in through the sensors that are out there on the machines, is well understood. But as you mentioned, thermography. We can take a look at thermography in multiple ways. We can convert those wavelengths, of the thermography into numbers and then crunch them and come up with insights. Or we can even look at them in a straight visual light of looking at the different color deviations and looking for patterns of that deviation in a visual screen. That's more of the imagination side, but it's also imagination that is being tested and being perfected in that. We can also take a look at different tools that are in our belt that can help work together by synergy. Predictive analytics, predictive reliability centered numbers is one thing that we're looking for pieces of equipment on there. But we also have a concept of taking your performance analytics around that. Now, how well is something performing? Now, can we merge these two? Can we get a synergy by merging these two, of taking the predictive analytic and we take the performance analytic and feed one into the other, or have them work together and provide a combined insight back out? That is where AI is now even pushing further. So not only are we getting the raw insights from the raw data itself, we're now getting those KPIs basically forming more of an insight to give deeper understanding and a higher dynamic range of those models that we can make in order to get that feedback. And then we connect it with the historian visualization that may be looking at that and then feed it back through. So, we talked about Pi, for example. You have a Pi vision screen. We can take predictive analytics outputs and performance analytics outputs and feed them back into, along with the analytics directly from the historian, and put it in one particular HMI type screen to make it actually accessible to somebody to see. And that's one of the things, is that all these data, all these insights need to, in the end, consider how are we going to use it in the field. How can I make sure to provide actionable insights and good value data in a way that does not overload somebody who is already probably overloaded, with their day-to-day tasks. Right. You want to bring something that's pertinent to them, to be able to see that they can see, hey, this was under my radar. This was outside of my screen of, my vision of what I was looking at right now. You can only look at so much as one human being. You can only evaluate, and typically, right. I always like to use the analogy of, you you go back to the Lord of the Rings, right? You know, the big eye's looking for the ring everywhere, and two little guys sneak up and chuck it in the volcano behind them. Well, if he could have actually seen them, he could have squashed that threat right away.
Right.
Same concept with issues that are going to try to break your plant. If you can see it, you can squish it. Right.
Yeah.
So.
Yeah, that's great. I appreciate that metaphor too. And I want to thank you very much for your time today. For those of you who are considering going to AVEVA's PyWorld Digital, that's next week from October 19th through 21st. Mike, are we going to see you there? Are you speaking?
I'm not speaking myself, but you will see some of our input will be showing up in some of those presentations, and I'll be there virtually.
Excellent. Well, I was always heard one does not simply walk into AVEVA PyWorld Digital.
That's true. The great eye sees all. Yes.
Well, thanks again, Mike, and thanks to everyone who listened to this episode. And take care, everyone.